Good afternoon, my YouTube viewers. Crystal here. I'm just here this afternoon because I want to make another code review for you. I decided I would do something on the monkeypox virus, and the reason why is because it's gaining a lot more attention. It seems like we still have COVID, but in addition to COVID, monkeypox has come along. And it's a virus that's transmitted by animals, and monkeys are animals that it's transmitted by, and humans can get it. And I do know, like in the town I live in, they've had people who've had monkeypox in the town I live in. I know that because I've got it from a very reliable source. And since monkeypox is gaining more and more momentum, I thought, oh, well, it'll be a good idea to do a time series analysis on the spread of this virus and see what we can find. So I got I'm using the Kaggle website. The monkeypox dataset, which is updated daily, is on the Kaggle website. So I just did my problem statement. It was a very short problem statement. Monkeypox is spreading worldwide and is considered to be a sexually transmitted disease by some. And so, some people consider it a sexually transmitted disease because you have to get up close and personal to get the disease. It's not like COVID was. COVID, you could just be standing right next to a person, and if you were standing right next to a person, you could get the virus. But monkeypox, it's a little bit more difficult to get. You have to have like close personal contact with a person to get it. So I decided to open a Jupyter notebook in the Kaggle directory. And so the first thing that I did was I imported the libraries. So I wanted to import NumPy as NP, which allows you to perform numeric computations and create NumPy arrays and also carry out linear algebra. I imported pandas as PD, which it performs data processing, but it also allows you to create data frames and manipulate them. I imported matplotlib pyplot as PLT. That's a graphics library. And I imported Seaborn as SNS. That's another graphics library that was written on the back of matplotlib. So after I imported my main libraries, I wanted to load the files. And so I used the OS library to do that. And then the files that we imported, we've got 3 files: monkeypox cases worldwide CSV, worldwide case detection timeline CSV, and daily country-wise confirmed cases CSV. So I thought, well, they've given me these 3 files, so let me see what I can do with them. So I had to read all of the 3 files in using pandas. So I read the first file, I called it worldwide. And then I read the second file, called it detection timeline. And then I read the third file and I called it confirmed cases. So in the detection timeline, they started keeping started keeping records. And the 6th of May, 2022, and England was the first country that they started keeping records. And if you wanted to, you could set it up to where you could get all of the dates, but it would be a really long data frame if you looked at all the dates. So I just use head and 10 to do that, which I suppose I should have done head and 10 and then tail and 10 so I could see the front and the back of it, but I didn't do that. Then confirmed cases. So we read the file in using pd.readcsv. So you can see all of the confirmed cases, and they tell you which countries are the confirmed cases. And again, I did head head of 10, so you can see the first 10 rows. I should have done tails 10 as well, so then you can see the last 10 rows. So now we're going to do the detection timeline date time. So detection timeline info. So you can see your information, and you can see that they're all object columns, and even the date is an object column. So we're going to convert the date to a date time using pandas. And so you can see now, if we check info, that now the date is a date time and not an object, which is what we want. So we also want to see which countries are represented in the detection date time. So we find out which countries are in the set, and then the good thing about a set is the set only includes like one instance of a country, and then it doesn't include any more. So that's why you can just do a set. And then we check the length of the set, and it's 61. So that tells you there are 61 countries. So now what we're going to do is we're going to group by the countries. So I decided I was going to make another column called none detected, and I was going to make it 1, because every time they had a case of monkeypox confirmed, they added a row. So I was just working on the assumption that every row was equating to only one person, and I do believe that to be correct. And the reason why is because the number of confirmed cases is the same as another data set. So I double checked it on another data set. So I do believe that in this instance, every row was one confirmed case. So we look at infections per country equals detection timeline dot group by country sum. So in Spain you had 2,034 cases. Germany you had 1,490 cases. England you had 1,482 cases. United States you had 790 cases. And I set it up so you can display the maximum rows, so you can see all of the countries represented. So that's going to be 61 rows. And then what I did was I sorted it in reverse ascending order. So the highest numbers on top and the lowest numbers on the bottom. So now we're going to group by infections on date. So infection per day equals detection timeline group by date confirmation dot sum. And then we're going to make it to where you're going to see every single row, and then infections per day. So you can see for the amount of time that they've been keeping records. They started keeping records on 6th of May 2022, and then they start so far 8th of July 2022 was the last incident we have. So now we're going to do a graphical representation of this. And so first thing we're going to do is we're going to describe our infections per day. So the count is 55, so that's 55 days, or 55 days they counted it. The mean is 164.93. STD is 209.64. That's standard deviation. Minimum is 1. 25% is 16. 50% is 94. 75% is 240. And the maximum is 1,061. So that means the maximum amount of cases they had in one day was 1,061. So we're going to check our max index. So we wanted to find the index number of the maximum date. And then so max index equals infection per day dot IDS max. So on 8 July 2022 is saying that you had your maximum index. I hope that's true. It says 1061, so that looks like that's correct. And then so we're going to plot it on a graph, and you can see that the numbers are going up. So monkeypox is a threat. It's not as much of a threat as COVID was, but it is a threat. So now what we're going to do is we're going to check England. So we're just going to filter England out and only look at England. And so there's the code to do that. And we're going to call it UK Pox. And so we're going to check the information, so you can see the date confirmation is the date time, and everything else except none detected is object. So UK Pox, none detected sum is 1482. So let's see, come over here. I think I remember it being correct. Let's just double check. Yep, UK is 1482, or England is 1482. So that's correct. UK table equals PD pivot table. UK Pox values equals none detected. Index equals date confirmation. And it's the sum. Aggregate function is the sum. So you can see that the days that they had all of the cases confirmed. And we're doing a graph of England monkeypox, and you can see that it's going up. It's steadily increasing, so there's an upward trend. So we want to check the table. These are your statistics of the table. Is 27 is your count, mean is 54, STD, that standard deviation, is 63.62, minimum is 1, 25% is 9, 50% is 24, 75% is 86.5, and maximum is 216. So that's the max cases that you had on any one day. And so what we wanted to do is UK max index equals UK table.idx max. And so it gave the num detected on June 20th, 2022 was the maximum number. So we look over here for June 20th, and it says 216, and so that was your maximum number. So that was good. We did a little bit of statistics, we did a little bit of time series, and we did a little bit of statistics. And I suppose I could have done a forecast, but I just thought that it's only been keeping records for about 2 months, so it's not going to give you a very reliable forecast, so I decided not to do a forecast. But that's our code review on the time series analysis of the monkeypox dataset, and it's updated every single day. So if you want to do your own analysis, then I will be giving you the link to the dataset and the blog post that I'm going to be writing on this. So I'm going to go ahead and conclude this video because I've talked enough, but I would like to thank all of my subscribers for supporting me and my channel. And if you like my video, please like, subscribe, and share. And thank you so much for watching my video. I look forward to making more videos for you in the future.